you about the analysis of variance. Analysis of variance is a differences test. Analysis of variance is basically a differences test that we discussed before, where our interested findings will be, we want to know the difference. As you know, there are two types of hypothesis or inferential statistic that you need to be mastered on, or you need to know lah, and you need to know how also. The first one is the differences test, to test about the differences between variables. And then the second one is the correlation or association, pengaruh ataupun perkaitan. So this is the two important element that you need to become familiar with. So in this case, now we are going to learn about the differences test, but this differences test is kind of similar with the independent sample t-test. Unfortunately, the most important difference of this testing is because we are going to test more than 2 groups. That's all. Okay, as we know, yesterday we already discussed about the t-test kan. The t-test are actually being used to measure differences between k is equal to 2. K is a group. Group is only 2 independent sample t-test. If we compare with standard, 1 sample t-test. If we compare more than 2, then you are need to go under the ANOVA, analysis of variance. So far so good? Okay. Analysis of variance got 3 assumptions that you must meet, or you got 3 requirements that you need to be considered before you can run for ANOVA. ANOVA lah kan. So the first assumption is your data must normal lah. Of course, this is a parametric analysis. The second one, your data must be collected from random sample. You know random sample or not? Random sample means that everybody inside this class or everybody in a population of interest got the equal chance to be selected as a sample. Okay. And then the third one, but not least, is the homogeneity of variance. So this one, homogeneity of variance. The first one, normal distribution, random samples, and then the third one will be the homogeneity of variance. Homogeneity of variance are being tested using the Levene test statistic. So the Levene statistic ni yang celah mana ni? Yang kita belajar semalam dalam independent sample t-test. If you conduct some t-test, it will appear something like this. Just giving you an example here. This one, did you see it? This is called Levene test for equality of variance. They are testing for the variance test. So same also, if we want to conduct the ANOVA, we need to request for the homogeneity of variance. Never mind, I'm going to explain to you after this. Okay, this is what I'm talking about, the homogeneity of variance. Homogeneity of variance must be more than alpha. Same like Kolmogorov, Smirnov, and Shapiro, Wills, whatsoever, must more than alpha 0.05. So that's mean our p-value example like this must be more than alpha. Then we can use our ANOVA. If less than alpha, you cannot use. You need to think otherwise lah. It's either you want to add up some more samples, or you can proceed with the non-parametric analysis. For the non-parametric analysis, for comparing more than 2 groups that is not normal distributed, or your samples are not collected from a random population or the random manner, so you might want to consider to use the non-parametric, what we call it as the Kruskal-Wallis, this one. Okay, how to find it is very simple. Under the analyze non-parametric legacy dialog, this one. K independence means that more than 2. The K is more than 2. If you see here 2 independent sample, this one is similar with the independent sample t-test, but this one we call it as the Mann-Whitney. So this one is the 2 related sample. 2 related sample is a paired sample t-test if data normal. If not normal, this one is what? Wilcoxon rank sum test. Very good. Okay. So the next one, we need to know the possible outcome. So if you measure some differences test using the ANOVA, you must understand ANOVA are actually a testing of differences between mean of the group. So we got mu1 is equal to mu2, and then another one is mu3 lah, of course, because must be more than 2 groups. Unfortunately, if you compare 3 groups, of course you have 3 possible outcome kan. Contohnya, mu1 is beza with mu2. Mu1 and mu3, how is it? You know? Contohnya yang kumpulan 1 dengan kumpulan 2 berbeza. Kumpulan 1 dengan kumpulan 3 beza ke tak? So kita nak kena tahu juga. So therefore, we have what we call it as a post-hoc analysis. Post-hoc analysis are meant to identify the specific group between the group. You got Malay, for example, you got Malay, you got Chinese, you got Indian. So Malay, Chinese and Indian, all these three groups are differ among these three groups. If they are differ, then we say that differ lah. Okay, and then between Malay and Chinese, and then between Malay and Indian, and then between Chinese and Indian only. That one also can be calculated and assumed and being produced by the ANOVA. But you must request for post-hoc analysis. I'm going to explain to you about the post-hoc, don't worry. Okay, the next one is the hypothesis of testing. The step is as follows lah. The first one, null and alternative hypothesis. The second one is alternative. And then we got the alpha is equal to jumhur ulama, and then we report the F ratio of the F statistic. During your study in the t-test, we are reporting what? T statistic. So for ANOVA, we are reporting the F statistic. Okay, that is the differences between the t-test and the f-test. So if you read inside journal, they put the f-test, so that's mean ANOVA. Very good, ladies and gentlemen. So this is the fourth step, and then the final step are as follows lah. Okay, let us look into the post-hoc comparison. Usually we are going to use the Turkey HSD, honestly significant difference. This one can be found inside your SPSS, so no need to worry, and you just tick for that, so that the analysis will be run for you. Okay, now let us begin with the example. Can we do this together? Very good. Okay, first of all, let us look into this condition or question. Data on perceptions towards management was gathered from random selected sample comprising of 3 employee group. The first one, we call it as supervisory, line, and support. Test the differences in the perception among the 3 groups. Are their perceptions high or not high? Okay, the higher perceptions means that they perceive good lah among their management. This is just an example, okay? So, the first one, state the appropriate null and alternative hypothesis. So, I'm going to ask you, what is our null and appropriate hypothesis alternative? What do you think? The first step. Excuse me. Okay, very good. Mu for supervisor is equal to mu line is equal to mu support. So this is our first null hypothesis. So what about our alternative hypothesis? Not all the same lah. Not all mean are the same. Are the same. Okay, that is our first step, which is we stated our null and alternative hypothesis, and then the second one, report the value. So to report the value and also to state your decision and conclusion, we need to run the analysis. Okay, let us run together the analysis of this particular example. Are you ready already? Are you ready already pula File, new, and then open new data sheet. You open new data sheet, the blank one like this, and then please follow me, and then we can do it together lah. Or you want do it first? You do it first lah, because I know already how to key in. I want you to make a revision first. So now, please setting your variable, and then you can find here is your how many cases? 1, 2, 3, 4. You try buat lah berapa banyak Nampak kan? Okay, you do it first. I'm going to explaining to you about the ANOVA. As I mentioned to you before, you must completing all the document like this. Okay. So the first step that you need to do is actually setting up the variables as indicate inside the notes. So the first one, I'm going to set the group and then perception. Or you can do like this lah kan, X1 and Y. X1 is your group, and then Y is your perception. So it's either one, it's all up to you. So we got here, X1 as a group is a nominal data because this is nominal scale lah. And then the next one is the Y as the perception is the numeric scale. Okay, so far so good. So we assume that the data is normally distributed and also being collected from a random samples. So now we are going to run the analysis. So the first one, you click analyze, and then you go to the compare mean, and then you go to the one-way ANOVA. Okay, you proceed with the one-way ANOVA, you click this button, and then it will come out like this lah, one-way ANOVA for the group and perception. Okay, I make a repetition, you click here, analyze, go to the compare mean, and then go to the one-way ANOVA. So far so good. Very good. Okay, the ANOVA, one-way ANOVA box will be appear inside your view, and then please put your numeric scale or your DV inside the dependent list. So if you're not sure what to put here, you see the name of the box here. The box say that there is the dependent list. So when you think about dependent list, you must understand lah, this is about the numeric data that you want to measure their difference. Okay, so the truth is you want to measure the differences between group, correct? So please bring your group inside the factor. Okay, finish? Okay, now go to the contrast and then click cancel. Saja je memang. Just kidding, okay? And then go to the post-hoc analysis. So based on the explaining topics before, you need to tick the Turkey. Tick the Turkey HSD. Honestly, test for the honestly significant difference. And then you can see here the significant level is 0.05. It's just similar like what being asked inside the question. And then you click continue. Okay, so far so good. Follow or not follow? Okay, I make Turkey SSJ sahaja. Okay, I make repetition. Go to analyze. Go to the compare mean and one-way ANOVA. And then proceed with the perception inside the dependent list. And then bring your group inside the factor. After that, go to the post-hoc analysis and then click for Turkey. And after that, check your significant level. Okay, this is my significant levels. That's good. And then you click continue button. After you click continue button, go to the next radio button here, which is we call it as an option button. Inside the option button, you must tick following procedure. The first one is descriptive statistic. You want a descriptive statistic of the data. The second one will be the homogeneity of variance. Homogeneity of variance, and then the last one, perhaps you want to see the means plot. This is the three most common analysis that you might want to request from the ANOVA analysis to be produced for you. Okay, so far so good. I made a repetition. Go to the post-hoc, please tick the Turkey and then click continue, and then go to the option, please tick the descriptive, homogeneity of variance and means plot. Bronze and Welsh is another form of statistic analysis. When you go to Sekolah Pondok, you can ask your lecturer, okay? And then go to the continue button and then click OK. After you clicking the OK button, the result are going to come out like this. Okay, the result are going to come out like this. Okay, I rerun again. The result will be come out like this. So you got the first one is the descriptive statistic of the data. So this is a descriptive statistic of the data. We have here is the mean and standard deviation and standard error, lower boundary, upper boundary, minimum and maximum of the data in terms of the supervisory group, followed by the line group and support group. You got 9, 10 and 20, the total number of the people that are being selected based on that group. Okay, the first one that you need to understand is the test of homogeneity of variance. As we said, as we discussed before, the significant level must be more than alpha, which is 0.05. So in this case, we got 0.825. That's mean more than or less than? That's mean ANOVA can be proceed or khalas. Silakan, proceed. You can proceed your ANOVA. Okay, after you finish observing that we can proceed the ANOVA, then this is the ANOVA table that want to answer to your question. Your question or your hypothesis is actually you want to compare the mu1, mu2 and mu3, correct? This is your null hypothesis, and then your alternative hypothesis will be mu1 is not the same with the mu2 and then not the same also with the mu3. Okay. This is testing. This one is the assumption. Assumption that you want to make sure assumption is met or assumption is not met. Your variance must be homogeneous. So if you want your variance to be homogeneous, frankly speaking, or easy for you to understand, this one must more than alpha. Because the test of homogeneity of variance also got the hypothesis testing. The hypothesis of the homogeneity of variance is the null hypothesis of the homogeneity of variance will be what? Data are similar variance. Data not similar variance. So when more than alpha, that means you fail to reject null, kan? And therefore you say that data are homogeneous, variance are the same. That one I don't want you to remember because it will make you confused. Therefore, I said before, when you say the test of homogeneity of variance, you look into SIG. If more than alpha, ANOVA can be used. So to test the real differences between group that our interest just now is not this one. This one. This is the ANOVA table, the F statistic here. Okay. So the F statistic are being measured 27.542 and our P is equal to P less than 0.001. If you see something that you cannot see what is the behind of that, you must put like this. Don't put like this, don't put like this. Because 0.00 in the mathematical manner, no meaning. What you are talking about? This is the mark I am giving to the student actually. Now, so after we see the ANOVA table here, the significant value is less than 0.001. So that means it's less than our alpha or more than our alpha. Our alpha is equal to 0.05. More than or less than? Less than. If you say less than, then we reject or fail to reject our null hypothesis. Correct. So we reject our null hypothesis and therefore we making a conclusion based on our alternative hypothesis. And therefore, what is your conclusion? What do you think? The conclusions that you need to withdraw from this particular case or from this particular exercise. So we are going to say there is a significant difference of the perception towards management between what? Between group of workers. Okay, group of workers at the significant value 0.05. Okay, and therefore you might want to continue say something lah about their mean, where the mean of supervisor indicate 30.33 plus minus standard deviation. Line is equal to 21.1, which is the highest perception will be the supervisory level rather than the other group of workers. Okay, so far so good. Understand or not? Very good. Okay, under the ANOVA table, this is what I'm talking to you about, the post-hoc analysis or post-hoc test. Okay, why we need a post-hoc? Post-hoc are actually to see the difference is in between which one. For example, this one kan, you want to see supervisor and line. Got different or not? Got different. This one, supervisor and support. Got different or not? Got different. You see the second one, the line and supervisor. Got different or not? Got different. You see another one, the line and support. Got different or not? No different. Because no star here. You can see no star here. And also the SIG are more than our alpha. And therefore, we are going to say, yes, they are different among these three groups. But if we look into the comparative manner between two groups on each of the group, we can see that supervisor are differ with line and supervisor are differ with support. Unfortunately, for line are not differ with the support. That means the line and support group are similarly have same perceptions towards the management. Okay, if you can see more clearer inside this one, we call it as a means plot. Therefore, we produce the means plot so that you can see, oh, supervisor with line and supervisor with support have huge differences. Unfortunately, the not significant one will be the line and the support. So that means the line group and the support group probably have the similar perceptions towards the management. Okay, so far so good, ladies and gentlemen. Any question, members of the floor? Anything that you want to ask before we proceed with the other test? Nothing to ask, eh? Understand or not? If you do not want to ask, that means you understand, okay? So now, example. X example. If your data is not normal, then you are going to proceed with the non-parametric. Let me show you straight away how to run the non-parametric. Can we? Okay, the first step is go to the analyze and then go to your non-parametric test and then go to your legacy dialog and proceed with the K independent samples. This is the example if your data is not normal. Okay, I made a repetition here. Go to the analyze. I'm so sorry about this. Go to analyze, go to the non-parametric analysis, go to legacy dialog and proceed with the K independent samples. So this one, if your data is not normal. So this one is a non-parametric test for measuring the differences between the three groups. If you find out that your data is not normal, if you find out that your ANOVA cannot be proceed due to a certain violation, and then you put the same thing, test variable list, you put the perception score, and X1 you put inside the grouping variables. And then the computer are going to ask you, what is the defined range? So you know already, my range is between 1 until 3. Why? Because I put the number 1 for supervisory, number 2 for line, number 3 for support. Therefore, they say that the minimum and maximum range of what? Range of your coding for that particular attributes. And therefore, I'm going to click continue. And as default, the computer are going to select the Kruskal-Wallis test. And then you can just hit the OK button. And this kind of output are going to be come out from your tables. And then where is our interpretation? So our interpretations are looking into this. This is our chi-square value. And this is our assumption significant values based on Kruskal-Wallis test. So based on the Kruskal-Wallis test, we find out that the P value is less than 0.01, which is this one, is less than 0.05, which is our alpha, and therefore we reject also our null hypothesis. And then we say that the mean rank, this one are talking about the mean rank, okay? The previous one are talking about the mean. This one is mean rank. So the mean rank between the three groups are differ. So that's mean if you are working in the supervisory line, if you are working in the line, if you are working as a support group, you will have a different perceptions towards the management in this particular example. Unfortunately, the Kruskal-Wallis did not produce any means plot for you. And therefore, a lot of people are very cautious, are very keen, are very interested to make sure that their data is normal. Why? Because they can do a lot of good analysis, okay, as compared to non-parametric tests. Okay, ladies and gentlemen, now proceed with our real data. Our real data that we already collected yesterday, which is the data for analysis.sav. Can you please open that data now? All, from all of you lah. So I'm going to investigate and identify. As you know, we got 3 objectives, correct? The first objective is to identify and also study about the demographic of the respondent. The second one is to determine and compare the level of awareness among respondents between their different demographic factors. And then the third one, to determine the relationship or association between the demographic factors and also their level of awareness. So this is our objective of the study. If you cannot cope with the objective of the study, never mind, you can refer back to these videos, okay? Make sure you make some revision lah. Otherwise, you don't have the clear idea about conducting your research. Okay, now ladies and gentlemen, I'm going to analyze for the B total. As you know, the B total is our DV, correct or not? B total are talking about the awareness level of the respondent regarding the lung cancer. So now we are going to analyze this thing and compare between the different groups, and that groups must be more than 3. So which one is more than 3 groups? Race, educational status. Correct? This one is the different DV. So how we want to do that is very simple. You just click analyze and then you go to the descriptive statistic and explore first, because we need to know whether the data is normal or not. Okay, let's say the data is normal. If the data is normal, then cancel lah. Let's say the data is normal. And then now the data is normal, we want to make a comparison between the different educational status. Our perception, we need to have some perception, you know. Our perception will be like this lah. I need to understand whether the people or the respondent here, let's say my respondent is the allied health student. So my perception will be like this. Oh, sorry. Education is 2 group only. Correct or not? Nobody remind me those things. Thank you. Thank you Allah for giving me the hint. I took another example which is the race. Okay, let's say I got this perception. What I mean by the perception, I may have a certain perception. Is the Malay are more cleverer than the Indian? Is the Indian are more cleverer than Malay? Is the Indian are more cleverer than, not cleverer lah, more aware than Chinese? So all these things are my preliminary assumption. And therefore, and that's why we develop hypothesis. And the first one, we establish the null. So my null will be the mu of the M Malay is similar with the mu of the Chinese, and then is similar with the mu of the Indian. So mu of what? Mu of the B total, which is the level of awareness that I want to compare with. If let's say there is different, that means one of the factors that might influence the awareness are the races. That means there are some cultural differences that make them more aware or less aware about these cases. You see, that's why we test for differences. Okay, and then the next one will be the H alternative, which is the hypothesis alternative. Of course lah, all the mean are not the same, ataupun all the mean are not equal, and therefore we are going to run this analysis. You can just click here, analyze, and then go to the compare mean and proceed with the one-way ANOVA. Under the table of the one-way ANOVA, you are going to select your clinical features, which is we call it as a B total inside the dependent list. Correct or not? And then please don't forget to choose your variable group of interest, which is we call it as a race. And then put inside the factor box. After that, do not forget to click the Posthoc and tick for Turkey. Okay, after that you click continue button, and then you click for the option button. After you click for the option button, tick 3 important statistical element that we want the computer produce: descriptive, homogeneity of variance, and the last one will be means plots. And then click continue, and then you hit the OK button. After you hit the OK button, the output I will be producing something like this. Unfortunately, there is less cases in the others group. You see, we got Malay, we got Indian, we got others. We don't get Chinese in our samples. It's okay. Unfortunately, our others ni adalah only 1 cases, and therefore the standard deviation is cannot be calculated lah. However, let's say we got some value here, never mind. So now I'm going to ask you some interpretation skill so that you understand. This is the homogeneity of variance. Is more than or less than our alpha? More than. So the ANOVA can be proceed? Yes. Very good. And this is our ANOVA table that will help us in our hypothesis testing. So we look into the SIG. Is the SIG or the p-value or the critical value is more than or less than alpha? More than alpha. If more than alpha, reject or fail to reject your null hypothesis. Excuse me. So fail to reject the null hypothesis, and therefore what is your conclusion then? There is no significant difference in terms of the awareness level between races. That means if you are Malay, if you are Indian, if you are others, you have a similar perception towards the level of awareness. If you see here, Malay indicate 7.5, Indian indicate 4, others indicate 5. It seems like the Malay got more aware, but actually it's not. It's similar, it's the same. But these data are not so good. Why? Because we don't have a good tabulation lah, because the others is not completed. Never mind. Now we are going to create one specific group so that we can reanalyze again the ANOVA with that new groups. Okay, we are going to make a group based on salary. Are you ready? We want to make a group based on the salary so that we divide the salary into 3 different groups. And after that, we are going to reanalyze the ANOVA using the factor of 3 different group of salary. Okay, so far you got the idea, right? Okay, but